She also advised that. She also has received a number of honors and recognitions. One being recently identified and selected as one of the 30 women in robotics you need to know by robohub.org. And she was also had a Reinvented Magazine Interview of the Year award on purpose and passion. And so with that, I'd like to turn it over to Carlotta.
Thank you so much. I wanted to thank Black in Robotics, IROS, as well as Amazon for having me. I didn't have a journey slide, but I noticed that Maynard and Ariel talked a little bit about their journey, so I will do that very quickly. My introduction into robotics was really late in life. It actually happened when I was an undergraduate student at Georgia Tech, and I took a robotics course, and I've told this story, so I know Ayana and Ariel have heard it. But in the class, they taught us all about robots, and we never touched a robot. So we had to write the code, we had to make algorithms. Then when it was time to go to the lab, they were like, oh, you undergrad can't touch the robot. So they went behind the screen, and we stood behind the cage and watched the grad students explore our code on the robot to see if it worked or not. So at that moment, I decided I want to be an engineering professor. I am going to create robotics classes for undergrads, and they're gonna touch robots. So I'm gonna talk a little bit about the integration of service education and research and how that all comes together in robotics. And I think it ties so well to everything we've heard already today, because I'm talking about grooming the roboticists of tomorrow and how we can do that to diversify the profession. So my first thing I like to always share with people is the vision for how I work. So I work at the edge of intersectionality, because being a Black woman in engineering and robotics is extremely rare. Some would call us a unicorn. So because of that, we have to wear several hats. And I think it works out so well because I can use my robotics to do that. I can use robotics to teach my students. I can use my robotics for outreach. I use it with my graduate students to do research. So that means that me as a professor, I have the scholarship of discovery, integration, application, and teaching, all because I do that. So what I like to live by is I bring robotics and STEM to people, and I bring people to robotics and STEM. And by doing that, I'm able to diversify the profession. And on Twitter, and you can follow me, I use the hashtag #NowhereSTEMiness to represent all of that. But it's about promoting STEM and robotics to diverse populations so that we do diversify the field, which Ayana mentioned earlier, because how can we design systems to improve the world if we don't reflect the world that we live in? So here are some examples of what it means to be a #NowhereSTEMiness. So I use robotics for teaching, which is what's happening here in this upper picture here. I'm teaching engineering design to some of my freshman students. I use robotics in the middle to do outreach for girls' summer camps. I also do FIRST robotics mentoring, as well as organizing competitions and being a judge. And I also am a judge advisor, so I teach other people how to judge FIRST robotics competitions. Down here is my daughter's Gamer Girls, which is a FIRST robotics Lego League team of Girl Scouts. So that's also how we promote it in the future. And then up here is research done with some of my undergraduate students as well. So I forgot to mention, I'm at Rose-Hulman Institute of Technology, which is a school of about 2,000 students. It's a STEM school in Terre Haute, Indiana, about an hour west of Indianapolis. We compete the most with Purdue, even though they don't know who we are. And so everything we do is focused on the undergraduate authentic education. We don't have any PhD students, and we have few master students that actually don't get a course-based master's. So here I share how we do robotics there. In order to grow this next generation of robotics, we look at multidisciplinary robotics, because we talk about that we groom engineers and computer scientists to go and work not in a silo. They're not going to go work in cubicles in a big building with nothing but computer scientists. So robotics is ideal for teaching them these connections between the disciplines. So in order to get a robotics minor at Rose-Hulman, a computer science must do some hardware work. An electrical engineer must know kinematics. A mechanical engineer has to do coding. So our multidisciplinary minor in robotics requires them to do this multidisciplinary work, and this creates these unique challenges because they have divergent interests, prerequisite skills, as well as hardware and programming ability. So the way we do that is we design our courses to be flexible enough for them to be able to accomplish that. So this is how we represent that. We have mechanical engineers, electrical and computer engineers, computer science and software engineers. They come together in these classes to get the minor, and then they also do a multidisciplinary senior design project. And we would love to have some projects from Amazon, just throwing that out there, because all of their projects are real world clients. Because we like to talk about that when the most important thing college can do for you is teach you how to talk to people who speak a different language from you and communicate clearly with them, and to work on real world open-ended projects. So we look for external clients for our senior design so that they're not just getting that pretty project that the professor made where they already know the answer and they're just giving you hints to get there. So I wanted to share a little bit of the way we do robotics at Rose-Hulman at all of our levels. So I'm going to show you a snippet of a video from our freshman engineering design class, a senior level mobile robotics class with all of those disciplines together, as well as some work from one of my graduate students. So here's the first one from our freshman competition. Welcome to the Monster Mash. And what we like to tell our students is whether you are interested in robotics or want to go into robotics or not, I can show you something on that robot that would interest you. If it's coding, if it's mechanical systems, if it's motors, if it's sensors, if it's controls. So that's the ideal thing about integrating robotics into different courses in the curriculum. If it's microcontrollers, if it's embedded systems, I can show you that. So that class I just showed you was made of students who may not necessarily be in robotics. But then this is a required course for our mobile robotics class. And this is an exercise where the students selected a different robot than the one I was teaching the class with, because they never think my robot is good enough because they're so tied to what they see on TV and they swear that's how robots work in the real world. So in this video, this student had his own robot and he wanted to prove to me that he could do everything that I was requiring the class to do with his robot. So that's what this video is made of. And so this class is about control architecture. And their goal is to take the robot from a newborn baby to about the ability of a 3-year-old by the end of the class. So this video is showing him building up the robot's intelligence, starting with potential skills, obstacle avoidance, to PD, feedback control, wall following, then showing me that the robot can recognize when it loses a wall or when there's a wall in front, so that it can navigate in and out of corners and doors. And then moving on to doing things like, does it recognize it's in a hallway, but can now center itself? And all of this is done by using PD controllers. Now, once again, we're talking about some students who've never taken a controls course. So I've got students in the class who are mechanical, electrical, computer science, and software engineering. They've got to learn things that they've learned in their siloed department courses as well as things they have not. We also do Bradenberg vehicles. So they look at the different types of cycles, such as love of light, fear of light, aggression towards light, avoidance of light, etc. So here they're showing me that they can change the robot's behavior and how it responds to light, so that they can then build this on a state machine to make choices. So this is an example of hybrid control, where the robot is doing behavior-based control on light following. It's also going to use that path planning level, so that it recognizes the priority is now to get to that light, but it now has to plan its path back to the wall to determine where it left. So they're showing me that they can now build a state machine on their robot so that it can do these different behaviors as well. This course always ends with path planning, mapping, and localization. And the CS students always get excited about this because they can now show me that that A-star and D-star stuff that they learned in their artificial intelligence classes actually can be done on a robot. And the thing I love the most about this, I don't do anything. In fact, I'll be honest with you, when I first gave these assignments, I didn't even know it was gonna work. My main thing was I wanted the students to, I didn't get to do it when I was an undergrad. And the class has now gone so far beyond what I could have ever imagined, that this last year, I actually had them make human-robot interfaces to virtually design ways to engage with their robot, and they were able to figure that out. I have one more video, and then I'm going to be done because Ayana put me on a time limit. So I only have had very few grad students, but this is one I wanted to share with you because I have students every year that tell me how much my robot sucks. So I said, well, build me a better robot. So this one student for his graduate thesis built me a better robot. He built me a robot using all of the garage spare parts from all of the 5 generations of robots that we had thrown out in my class, and showed that he could design a modular robot that could be coded in whatever you wanted and in whatever language you wanted. So he showed that you could program it on a computer, a cell phone, an iPad, on the cloud. And then he's demonstrating that he could do all these behaviors on it and that you could make it plug and play, so that now this robot could be used in my mobile robotics course, and I don't have to worry about that a CS student doesn't know controls, or that the electrical engineering student is not that good at coding, because they now have the flexibility of language, whatever language they want to use and whatever platform they want to use. So I just want to wrap up by saying that the great thing about mobile robotics is that you can show the intersections between all of these disciplines. And because people from 9 to 99 get excited about a robot, you can also use it to diversify the profession by showing them how it can connect to what they do in their everyday life. And if you want to reach out to me, there's my website, my email, and follow me on Twitter.